Or message me if you can hear me and see my desktop. Can hear and see desktop. How about you, Faith? Lay. No, you didn't. Come on, you can do it. I think Mr. Bradshaw's trying to talk. Because every time I think he tries to talk, that blue thing shows up. She said lay, so I guess that means okay or yes. I don't know. Oh well. I'm recording, so let's get started. All right, let's put a complete square up there and rationalizing the denominator in a logarithm. So negative 2x squared minus 4x minus 6 is equal to 0, and 3 over I minus 4 log x squared y to the third. All right, do those three. Let's see how much you remember from last week, because none of you did any homework. At least you said you didn't. I'm trying to speak. I don't know what the hell happened. Maybe you want to try your phone. Download the app on your phone, Faith. Won't let me hear you. So I need to type that in. And write those three down. Now with the complete the square, I want you to do everything. I want you to find the vertex, the x-intercepts, sketch it, find the increase and decrease in values, domain and range. You having problems? Well, why don't you try your phone? Can you download the app on your phone? Okay. Okay. Well, then just restart your laptop and desktop, and then text me back. I'm gonna put my phone on sound, and just text me back, and I'll hear it. Okay. All right. I'll try to call you again. Bye bye. All the things I do for my students. Well, she's still there. Don't know how to get rid of her. Remove the meeting. Kick your butt out. Okay, make sure y'all can still see the desktop. Face, you there? No, she's typing.
It's okay.
It's Tandy. Okay, I think they're good. And I am recording, so. I have to turn this thing down because they are loud. -8. I'm sorry. -2. Y'all check me. -1, -4. Y-intercept is -6. And which way is it opening? Down, Hebert. That's that fast. Increasing from -infinity to -1. Decreasing from -1 to +infinity. Domain is all real numbers. Range is -infinity to -1. I'm sorry, -4. I still see people writing, so that means that y'all still knocking the cobwebs loose, because you should be able to complete the square like that. Those of you that came in a little bit less than early, I didn't send out for y'all because it was so much work. Somebody else? What's the conjugate of I -4? I plus 4. So we're going to multiply by I plus 4, and I plus 4. And this is the product rule. Log product and power. No yawning in class either. No sneezing or yawning. No coughing. Then we had to watch SpongeBob this weekend. My son wanted to watch SpongeBob all weekend. Which I like SpongeBob, so my favorite characters are Squidward and Plankton. I love to see him get run over and beat up. I'd like to take a baseball bat with a spike on the end of it to the starfish, Patrick. He's a damn idiot. I like horror movies, but I can't get into zombies. And everything on the frickin' TV this weekend was zombies. I don't like zombies. I don't like any movies on zombies. Yeah, I don't either, Hubert. Just sit around, get drunk, and depressed. Is that what you do?
I mean, I would love to do that.
Where do you work?
Later.
Oh, okay. I used to know the guy that used to head that plant, Mr. Blackston, Randall Blackston. He and I went to school together. Used to play pool 101 here at Tri-County Tech when we had the pool tables. For those of you that don't know, you know where the ramp is going down to the cafeteria, or whatever y'all call it. Right there where the counseling center is, that wasn't there. There was 3 or 4 pool tables right in there. We used to bring coolers with refreshments and sneak it in, and by the end of the day, we'd be feeling pretty good after we cut all our classes and gambled on pool tables. Yeah, I'm the cause of this damn Russians. Three times I plus 4 over I squared minus 4 squared. Shortcut number what? Shortcut number, you got a 20% chance. I heard, that's what I heard. Enunciate and volume. Enunciate means that if you're going to say cat, you say cat. You don't say, like y'all need voice messages. Number 3, good. You enunciated, whoever said that. Good. Number 3. Shortcut number 3. And that's going to give you 3i plus 12 over what? -1, Hubert. That's right, class. Minus what? 16, Hubert. 3i plus 12 over -17. Now, sometimes you might not want to factor distribute the 3 because that 3 might cancel, no sneezing, with whatever you got down here. So if that was a 15, you could actually knock 3 out of the 15 and get 5 with it. This one. Log of x squared y cubed. Product rule, because this is multiplication. Log of x squared plus the log of what? Y cubed. And what does the Power rule say? I can bring the exponent out in this case, and that'd be 2 log of x plus 3 log of y. And I think that's what we went over last time. We just got into the logarithms, correct? Because we need to do a couple of logarithmic equations, and then move into, I'm not going to do too much on the trigs, because for one, you can graph your trig equations on your calculator, and two, trig identities and trig derivatives are memorization. And that's why I gave you all the sheet. So you could have it to help memorize, especially the back. Turn to the back. No. People that are late, I threw them in the trash can. People easy. Yeah, I figured out this was a waste of time because I knew y'all probably got home and couldn't come back. I didn't know where it was. I don't know how to print stuff off the computer. See the back? Those are the two top ones are the most confusing. You remember the derivatives, derivative sines, cosine, derivative cosines, negative sine. But then when you do the integrals, you're like, you're like, I can't remember. It's the opposite. But you have to keep those two, the top two, you have to keep those memorized because you're going to make a careless mistake on a test. You're going to say, okay, the integral of the sine is the negative cosine or the positive cosine, whatever the wrong answer is. You got to keep them separate. So you might want to take out a highlighter and you might want to highlight those first two on each side because those will get you. The rest of them, not a big deal. On the identities, you want to always remember your reciprocal identities, the Pythagorean identities, for Calc 3, you're going to have to remember some of the more advanced ones, which are double angle identities and the half identities. So you don't have to do those right now, but you might want to mark them for Calc 3. You're going to use those a good bit. But for this course, the reciprocal identities, the first three, I think, is what you're going to need in here. And again, they're all memorization, so I'm not going to spend a lot of time on, okay, the derivative of sine is negative cosine or whatever. Derivative of sine is cosine, derivative of cosine is negative sine. I'm not going to sit here and explain that to you because it's based on identities and memorization. But I will put antiderivatives and derivatives on the review test just to make sure that you at least can look them up on your sheet because I doubt half of you are going to memorize them because that would take a little bit of what? Work. Okay? And besides, y'all already printed them out. All right. Let's go ahead and move on to the next review. I want to do a couple of change-based formula and a couple of equations. So let me pull up an equation right quick and just pull up some equations off the internet because I don't feel like looking them up in the book. So I'll just do log equations. PDF images. Okay, here's one. Log 1 minus 5x is equal to 1/2. Log 1 minus 5x is equal to 1/2. Log of 1 minus 5x is equal to 1/2. Now, there's two types of equations. One is the definition of logarithm, and the second is take the log of both sides. Okay, with me? There's two types of solving equations with log. This one is called definition of logarithm. Why do you not take the log of both sides? Because then you'd be taking the double log on the left side and the single log on the right side, and that's just whips and chains. And if you like that, then you're good. But if not, you might want to go with the definition of logarithm. Definition of logarithm says log base A of x is equal to what? Make sure I did that right. Sometimes I transpose the x and y. A to the y is equal to x. Okay, so that means I'm going to take, suppose 10 right here, because there's nothing there, so suppose 10, and I'm going to take my A, which is 10, raise it to the what? 1/2 power. And that's going to give me the square root of 10 is equal to 1 minus 5x. X is on the right hand side. I'm going to bring it over to the left hand side. And that doesn't make a rocket science to that square root of 10. The square root of 10 is 3.1. Because square root of 9 is 3. So 5x is equal to 1 plus or minus 3.1. X is equal to 1 plus or minus 3.1 over 5. X is equal to 1 plus 3.1 is 4.1. So 4/5 is 1. And 1 minus 3.1 is negative what? 2.1? Y'all check it, because $1, you owe $3.10. So that'd be $2.10, right? So negative $2.10 over 5, which is equal to, how many equals within a dollar? 20, right? So that'd be 40 plus 2, 42. Somebody check my math. Negative 0.42. Somebody check me. Thank you. Appreciate it. And chances are that negative is going to screw you up because you can't take the log of what? Negative. So negative times this is negative 5, or that'd be positive 5, so it might work. So you have to check both of them to make sure you don't get no solution. And you could pull up, just right quick, you can pull up your logarithmic properties. Again, Google is so good because you can pull stuff up like that. Log properties. And there they are. Let's see. Let me find a good one for you. There's the definition of a logarithm. This one might work. View image. Dang old snip. I hate that word. Snip. Not as much as some people hate the word moist, but I don't know why people hate the word moist. I don't care, but some people can't stand that word. I actually had one student we were talking about words that you don't like, and they just come up with a couple of, I mean, she just said the F-bomb, and I mean, she didn't say the F-bomb, she said the actual word, and made everybody uncomfortable, awkward moment. So I quit bringing that subject up. All right. So let's check our definition of a logarithm, make sure I got it right, because sometimes I transpose numbers. I take my medication, but it still doesn't work sometimes. So there it is. So let's see. Make it a little bit bigger for y'all that always sit on the back row that can't see. There it is. Make sure I just see. That's the. I didn't put the definition of a logarithm on there. Okay, write those down, and we'll pull the definition of a logarithm up next. You don't have to write all of them down. Just write the left side, because I gave you the right side last week, and I may have left out a couple of those first three. I left those off because those you should know those, but And I gave you, I think I gave you the last 4. The exponentials, the logarithm is based off the exponentials. The exponentials are on the right. You should know those from algebra 1 and 2. I ain't heard anything from them, so I guess they all right. I'm gonna lock that while y'all are. And I'll pull up the definition of a logarithm. I thought it was on that one. Here's the one I use. I'll just pull that up. Y'all got those written down? There's the definition of a logarithm. I use the first one, y is equal to log base a of x. A to the y is equal to x. That's what I use. So you do whatever you want to. But you don't have to write both of them. Just write the first one. I hope I did it right. I think I did. Okay. Now let's do another type equation. And this time, do the log of both sides. I'm going to do log both sides problems. Alright, 2 to the 4y plus 1 is equal to 3y. 2 to the 4y plus 1 is equal to 3y. 2 to the 4y plus 1 equal to 2y. I don't forgot it. Anybody remember it? Y'all suck. I'll forget it now. I'm already went back to look it up. 2 to the 4y plus 1 is equal to 3y. 2 to the 4y plus 1 is equal to 3y. 2 to the 4y plus 1 is equal to 3y or 3 to the y?
3y. That's good.
Okay. Is that it? I thought it was an exponent. Usually, whenever you see exponent, a variable in the exponent, most of the time you're either going to use the definition of a logarithm or you're going to be taking the log of both sides. Now you can take the natural log. I'm an LOG teacher, so I do the LOG. It doesn't matter, you get the same answer, okay? So if you like the natural log, use natural log. If you like the LOG, then use LOG. But just go ahead and everybody can do the next step. You put a LOG in front of the left side and LOG in front of the right side. Everybody can do that. Now you can meditate if you have no idea what to do after that. ever see where the Russians have done hacked poor old John Lewis's memory? Yep. Congressman from Georgia.
I'm sure they'll find a lot of them.
He's not going to attend the inauguration because the Russians elected Donald Trump, and Donald Trump's not our president. And this is the first inauguration that he's missed as a congressman. Well, he neglected to remember that he missed George W. Bush's inauguration because he said back then that George W. Bush wasn't president because Al Gore won. The Russians done hacked into his brain. And just think, we got these people in D.C. representing us. And people like Lindsey Graham. Well, he's a disappointment. I'm officially going to run against Lindsey Graham. I'm going to go to D.C. and make all that money and not have to do anything. Lifetime retirement. $100,000 a year for the rest of your life. To sit up there and say yay and nay. Okay, so everybody can put LOG in front of, everybody can do that? And then you just sit there, right? LOG of 2 to the 4y plus 1 is equal to LOG of 3 to the y. Now what? I heard no. What? What rule is that called? The power rule. Use the power rule. Bring it out front. And that gives you 4y plus 1, parentheses, LOG of 2 is equal to y times LOG of 3. Now this is where students usually get confused. They'll go, I don't know what to do next. Well, always remember this. Right here, and especially when you get to Calc 3 and you get to differential equations, log of a number is always going to give you a what? A number. Okay, so if I take you back to pre-algebra and I change this to 4x plus 1 times 2 is equal to x times 3, and you'll say, okay, that's 2 times 4x plus 1 is equal to what? And then you won't finish the problem, right? Well, what are these two guys right here? What are these two guys? They're what? They're numbers. So either treat them like numbers or put them in your calculator and turn them into numbers. Whichever one you want to do. So go ahead and either think they're numbers or take your calculator out, turn them into numbers, and turn it into a pre-algebra problem or algebra 1 problem. But a lot of people, especially in differential equations, they get these logarithms and you're talking about big, long problems and they don't know what to do. Just remember, a log of a number is a number. And that'll take you back to your algebra 1 and algebra 2 properties. Okay? Or, if you want to treat it like a number, then you do what with this? Oh, shit. You do what with this? What do we do with that? Distribute. So now whether you turn it into a decimal or you just treat it like a number, you just go 4y times log of 2 plus 1 times log of 2 is equal to
You
log
have
of
a work
3
email.
times y. And the reason I put the log of 3 in front of the y is because what is the log of 3? It's a number. And now you can change those into numbers and finish the problem. So somebody give me the log of 2. What is the log of 2 in your calculator? Just give me the first decimal place. 0.2, 1.3, what is it? I'm sorry, what? 0.3 plus 0.3 is equal to, what's the log of 3? 0.5. Now everybody finish that problem. Because now it's just an algebra 1 problem. Actually, you can turn them all into whole numbers and multiply them by 10 all the way through. But I'm not going to do that because some of y'all's hidden notes work. Well, 10% of 4 would be 0.4. So 0.4 times 3 is 1.2.
Facebook message.
So 1.2 y plus 0.3 is equal to 0.5 y. And I want to keep my variable positive, so I'm going to move the smallest bucket. The smallest bucket is 1.2. No, the smallest bucket is 50 cents. So I'm going to bring the 50 cent over plus 0.5 y. So that's going to give me $1.20 plus 50 cents, $1.70 is equal to negative 0.3 divided by 1.7.
That's minus.
Okay, everybody wants to talk at one time again. Well, you know, I ask y'all questions and it's like this. I make a mistake and oh hell no! Yeah, exactly. Negative 1.2, so $1.20 minus 0.5 minus 50 cents is
0.7.
0.7. Thank you. Oh hell no, that's not right. Now divide by 0.7, and I brought the negative 3 over. 0.7. Somebody give me the y. Y is equal to negative what? Enunciate and volume. Point 3 divided by 0.7. 0.4. And your 0.4 will go up there and let's see what happens. 2 to the 4 times 0.4 plus 1 is equal to 3 to the 0.4. Now 4 times 0.4 is 1.6, right? And that's going to be 2 to the 1.6 plus 1 is 2 to the 2.6 is equal to 3 to the 0.4. Somebody raise 2 to the 2.6. What do you get?
Mm.
6.06. Did everybody get that? Now, raise 3 to the 0.4. What do you get? Something's wrong, man. It's supposed to be equal. 3 to the 0.4. No, negative 4. Thank you. 3 to the negative 4, which would be 1 over 3 to the 0.4. So 1 over 3 to the 0.4. It does, yeah, it does. Thank you. I knew something was wrong because when you said 1.245, then I got trained. That's negative 0.4 and negative 0.4. Sorry about that. So negative 2 to the negative 1.6 plus 1 is equal to 3 to the negative 0.4. Negative 1.6 is negative 6, so that'd be 1 over 2 to the 0.6 is equal to 1 over 3 to the 0.4. And what's 1 over 2 to the 0.6? 1.5. And what's 1 over 3 to the 0.4? Supposed to be the same. What can that be? $1.5. It comes out to be the same. We didn't do all the rounding we were supposed to, but you're supposed to see that it comes out about the same. Okay? That's the check. If we would have carried everything out to the 5th digit, then you'd come out the same. I'm talking about down here. Okay? Now, that's that. The derivatives. Let's go over the derivative rules and basic integral rules. Because I have no idea where we're supposed to start. I think we're supposed to start with substitution, right? And the substitution or integration by parts. I can't remember. We'll look at it. So, basic derivatives. And I'm just going to go over this because a lot of people don't remember it. 2 points on a line. 2 points. This is x of 1. And this is f of x of 1. Or y. This is x of 2. And this is f of x of 2. Or y2. Now from your basic algebra days, the slope is equal to delta y over delta what? X. And that's equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And in that case, y sub 2 is f of x sub 2, right? Yes, you do. F of x sub 2 minus f of x of what? 1 over x sub 2 minus x sub 1. Of course, as those were numbers, you just plug them in, right? Let's see, this is a 2, 2, 2, 3, and this is 5, 5. We read from left to right. This is x of 1, y sub 1. This is x sub 2, y sub 2. Take those numbers, plug them in. 5 minus 3 over 5 minus 2, which is equal to 2/3. I'll check them. Okay? So the slope is 2/3. Everybody remembers that from algebra. Okay? Now we take this guy. This is algebra 1 and 2. And college algebra. Now we take what we learned in algebra, and then we do a little bit different. In algebra, we did the straight line. But in calculus, we do curves. Now, the interior of the curve, straight line between 2 points, is the interior of the curve, which is called the what line? Starts with an S. Secant. Good. Some of y'all learned that. Some of y'all had good teaching. No comments. All right, that's the secant line. Well, the secant line doesn't do us any good in Calc 3 in physics because we got to have the normal vector. And the normal vector is off 90 degrees off the what? Tangent. That's right, class. So the tangent we need right here. Well, this is x of 1, or x. I'm just going to call it x. And this is f of what? F of x. And the distance between here and x of 2 is h. That's the distance. Some people use d. I use h. So this x point would not be x. It would be x plus what? H. And this is f of x plus h. Is everybody with me? So this point right here is parentheses x f of x. And this point is x plus h and f of x plus h. Everybody with me? That's the point here, and this point here. Find the slope between the 2 points on the secant line using these 2 points, this x and this y, and this x and this y. Who's that? Plug it into this right here. The reason I do this is because a lot of people forget what they're actually doing. Using algebra to actually find slope, just like you learned back in pre-algebra or algebra. This is your x of 1. This is your y of 1. This is your x of 2. This is your y of 2. Now, I tell students, whenever you find a slope, you use a big set of parentheses. Okay, what's our y sub 2? That's what x plus x. And what's our y sub 1? F of x. And what's our x of 2? And what's our x of 1? All right, simplify this. There's only one thing that simplifies. And what's that? The x on the bottom, that's right, class. Appreciate the interaction. Makes class go by a whole lot faster. That's all for you actually taught. What's x minus x? And that leaves you with h. Oh my goodness, what is this called? It's called the slope. Are we still using algebra? Have we done any calculus yet? No. Now, back along after you finished algebra, you did a little bit of trig, which is what, memorization. And then you came into calculus and went over some algebra, went over some trig, and then the calculus teacher totally confused you with limits. Unless you had limits. Okay? And limits, here's a wall, and here's you, and you have a 4-foot stride, and
Facebook
you're
message.
supposed to take a step, or you're supposed to work your way to that wall over there. And each time, you'd have to take half of the previous step. So the next step, what would it be? What would your stride be? And what would the next one be? And the next one would be 1/2. And the next one would be 1/4. And the next one would be 1/8. Would you ever reach the wall? No. You never will reach the wall. What will you do? You'll get right up next to it. So the limit basically says that you what? 25-cent word, you converge, and you get right up next to that point, to that wall. So you take your algebra that you learn, and you add it to the limit, and you have calculus. You have the derivative. Okay? So, let's do that. Let's say f of x is equal to x squared plus 1. And you say, I want to find the derivative of that, but I don't know any calculus yet. So, just get on out of here. Quit. Limit as h approaches 0, because you get closer and closer to that wall. And what happens when you get closer and closer to that wall, the secant line becomes the what? Okay, my students, you can talk. What does the secant line become? The secant line is this guy. After one step, after one step, after one step, after one step, after one step. H approaches what? 0. H is right there. The hair width from x. So what does your secant line become? The tangent line. Okay? The secant line becomes the tangent line. And once you find the tangent line on the particle in space, you can find the normal vector, which is your velocity. Okay? So, pretty good for a redneck, isn't it? All right, so limit as h approaches 0 of f of x plus 2, so that meant f of x plus h, which means I've got to write parentheses squared plus 1, close parentheses, minus f of x, which is x squared plus 1, oops, over h. Now, what goes, when you take f of x plus h, that means wherever there's a parenthesis, what do you got to do? Plug in what? X plus h. All right, now do that. So you got to do shortcut number what? 1, Hubert. That's right, class.
You have a work email.
That means I'm fired, brother. Give the cat away. You'll haunt somebody else's house. was telling somebody about the fruitcake lady this weekend, and they went, "Who's that?" It's your parents' fault. You ever seen the fruitcake lady? It's your parents' fault. Just Google it. The fruitcake lady. She'll answer all your questions. Can't believe y'all have never seen the fruitcake lady. You're crazy as hell. That's why you don't have a job. You're stupid. One guy had all these piercings all over his face and tattoos all over his face and bone through his nose. He goes, "Fruitcake lady, I was wondering why I can't get a job." And she said, "Look at you, you crazy as hell. Nobody's gonna hire you looking like you look." All right, so what do? Well, limit as h approaches 0 of x squared plus 2xh plus h squared plus 1 minus x squared minus 1. And what happens to all the x terms and numbers? What happens to them? Or is that supposed to happen?
Yes.
Yes. And that leaves you with all the h terms. And you factor out of h, limit as h approaches 0 of 2x, h times 2x plus h over h, and the h's do what? And limit as h approaches 0 of 2x plus h. And what happens to the h as h approaches 0? What happens to it? Goes away, Hubert. And that leaves you with what? 2x. Now what is 2x? The derivative of x squared plus 8, x squared plus 1. But what is 2x? It's the derivative, but what is it? It's the equation of the tangent line. So x squared plus 1, dang old chart, dang old x squared plus 1. Pick a number, -6. What's the equation of that line at -6? Or what is the slope of that line at -6? What's 2 times -6? I'm asking y'all. -12/1. So the slope of that line at that point in space is 12/1. And if you found the tangent line, then guess what? You can find the normal vector. Well, what about on the other side? 8. Eight times 2 is what? The slope of the line there is 16 over what? And that is taking your algebra plus your calculus, plus your limit, and you put them together, and you have your derivative, which is the equation of the tangent line at any point in space. Or you could just use your basic law of derivatives, which is 2x. Okay, that's your basic law of derivatives. What's your other derivative laws? There's 3 of them, 3 main ones. There's the basic law, basic derivative law, power rule, basic derivative power rule, which we just did, which means a to the n is equal to n times a to the n minus 1. Okay, what's the next rule? That's not rhetorical. I'm asking you to give me feedback. What's the next rule? Boom. That's what I heard. No. Enunciate and volume. What is the next rule? The what? Well, before that. What's the opposite of quotient? Product rule. Good. First times the derivative of the second plus the second times the derivative of the what? Quotient rule. Denominator times numerator prime minus the numerator times the denominator prime over denominator what? And then what's the last rule? Chain rule. Which basically says anything in parentheses, a plus 1 raised to a n power is equal to n times whatever you have to begin with to the n minus 1, but you also have to take the derivative of what? What I tell my students, what's inside? I'm going to pick on you because you said you had, when was the last time you had calculus? Okay, is this knocking some cobwebs loose? Good. Did you forget any of it?
I don't remember the change.
Good. I mean, not good that you don't remember, but good that I'm covering because I don't want you to fail, even though I do want you to fail. That's a long story. Okay? So, let's do a couple of these. 2x to the 1/2. 1/2 x to the negative 4. Trying to think of a good. Four times x minus 1 to the 1/2. No, let's make that just a 2. Do the power rule here, I mean the product rule here. So let's do the basic product quotient 4x 5x squared over 2x. Use the quotient there. And then 2x squared, or 2x, well, let's just do 2. We'll do the chain rule here. X minus 4, 2x minus 4 raised to the 5th power. That's just some little bit of, you'll have plenty on your homework. Oh well, guys, I'm sorry, but Kate Mara is officially engaged. That's what's on Facebook. I'm just reading. That's what it says. It says she's off the market. Evidently she's an actress. You ever say? I think she's the way she. I'm looking at a picture of her. She was the girl on Shooter, with Mark Wahlberg. I take stock, guys. Sandra Bullock, she is not. But evidently they think she's famous because it says is officially off the market. She is officially engaged. You know what I've seen the last couple of years? Hollywood movie stars thinking they're more famous than they really are. Have you noticed that in the last couple of years? Okay, y'all not going to talk to me. I don't know why I'm wasting my breath. Huh? Well, I do because I watch a lot of movies. I like movies. I'd rather watch movies than, well, I don't watch the NFL anymore. But I watch college football, but that's it. But I don't watch any other sport but college football. I used to watch golf, but I don't watch it anymore because I can't play it anymore. So I guess I should start playing more golf because instead of watching movies, I quit playing golf.
You could.
Yeah. Maybe with a fifth of Jack Daniels and some beer,
Great.
All right, so what's 2x squared? 1/2 times 2 is what?
1.
1, so that's x to the what? What's 1/2 minus 2/2? To the negative 1/2, and what happens? That's x, so 1 over what? Square root of x, which is equal to the square root of x over what? X. And I guarantee you, half of you didn't take it out that far. Why? Because you suck, that's why. We might as well just come to the conclusion. Negative 4 times 1/2 x to the negative 4 minus 1. What's half of negative 4? Negative 2, Hubert. That's right, class. X to the negative 5th, which is equal to negative 2 over x to the 5th. Product rule. First, times the derivative of the second. I put in the chain here. Okay, first times the derivative of the second, which will be 2x minus 1 to the first power times 1 plus the second x minus 1 to the second times the derivative of the first, which is 0. I'll do that one for you. That goes out. And you're left with 8 over x minus 1. Quotient rule, denominator times numerator prime minus the numerator times the denominator prime over denominator squared. Now what do you got to watch out for here? The quotient rule, you got to watch out for what? This guy right here. And that's why I put parentheses right here because of the picture. Okay? $20x squared minus what? 10x squared? Y'all check me. Over 4x squared, which is equal to 10x squared over 4x squared, which is equal to 5 halves. Is that what y'all got? Yes, you were. Then the last one, 5 times 2 is what? 2x minus 4, 5 minus 1, and then what's the derivative of 2x minus 4? 2. And 2 times 10 is 20 times x, 2x minus 4 to the what? 4th power. That's the chamber. Knocks the cobwebs loose. Okay, now that's got you up to about 5 homeworks. Okay, we're going to stop here before we go into antiderivatives because you need to be able to get through the derivatives so I can knock the cobwebs loose on the antiderivatives. So we're probably talking about starting Unit 1. What day is today?
Tuesday.
Either the latter part of Thursday or next Tuesday. So you need to get that homework. I'm not going to put any new homework up. I've got about 6 or 8 sections of homework up. You need to get that done before next Tuesday. Okay, let me get the roll and let's check on our. Well, where is our? There it is. Skype. How we doing, y'all? Y'all still on there? Everything good? Okay, both of y'all said everything's good. All right, I'm going to end the call. I'll give y'all credit for being here. Y'all be good.